Добрый день, коллеги.
Hello, colleagues. My name is Ivan Novikov. I am the CEO of Wallarm and an information security expert. Today, I'm going to talk about the security of API and microservices and what is the purpose of application firewall, web application firewall, next generation application firewall, and various other security and API protection products. First of all, it is worth understanding what an API is in general, what we will mean by it, as the definition is quite broad. The correct definition essentially determines how we approach protecting this or that object, in this case the API. As our customers say, to protect something unnecessary, you have to implement something unnecessary, and we don't have resources for that. Still, APIs, oddly enough, make up almost all of the modern internet, and that's the reality. In general, we can say that APIs are sites for robots, if we're talking about web-based API, and in this report we will be talking, of course, about application programming interface for the web, so exactly for what happens on the internet. Websites for robots are probably the easiest definition to get. There are no pictures, there's nothing over there but the data themselves, and it's a direct interface to data that can be used by your website or any other B2B application. Sometimes a thick client, sometimes a mobile app if we're talking about mobile app backends, to communicate and get data directly for your database or any other business logic object. Roughly speaking, it is an application interface for other applications. These other applications can be websites, mobile devices, integration things, and so on. And if there is a user interface for a person, there is an API for some software. Integration between business applications, for instance, enterprise service bus. If you've been involved with enterprise products such as SAP API or various ESB products, it's exactly the same as using API for API and for integration. But if you've been in IT for a long time, you probably know that there used to be an integration through protocols like SOIP based on XML files. They were quite heavy. Now we're shrinking in terms of data size. And there came the protocol JSON, REST API, then binary data, now the protocol similar to gRPC, even more capacity-taken data so that the compression is built into the format itself, and so on. There are message pack and other data formats. The API does not change as a concept because of that. It only changes the data transfer format that has to be kept in mind. Where do we see APIs in real life? First of all, it's any application, maybe a client bank website, maybe any other web resource, portal, electronic trading platform, anything. Everything that we call SPA, single-page application, is conventionally, where you don't have to update the whole page to go to another section, that's a single page. Under the hood of that is a backend application. It is essentially a site that constitutes two software programs. One program is in JavaScript is called a front-end program. We can come across it in frameworks such as React, Tango. It's not so important anymore, and it communicates directly with the data by API. That is, it sends queries, usually via REST, when it comes to JavaScript, and gets responses back, and accordingly it draws the data. This way we don't have to download page templates as we did in the HTML before the SPA. Sites work faster, and the person experience with that site is much more straightforward. Mobile app backends. Well, we all use mobile phones, and of course, what a mobile client sees on the screen, that data is obtained by API. There are already binary protocols such as gRPC, which directly sends data to our phone. Mobile bank app and any other mobile app will usually use an API, and instead of a browser, if we use a desktop, a laptop, or a browser such as Safari, there will be a special client, essentially a fat client or mobile application. That will draw this data in the right way and replace that JavaScript application I have mentioned earlier. This is a B2B integration. The interface, the integration data bus, about which we have already talked a little bit earlier. Here are some examples of API integration to SAP, Oracle, everything that is moved from here to there, ERP, CRM, all of those are based on APIs. Firm-wide services and systems such as Exchange, Active Directory, or any other internal services, internal employee portals, APIs for HR systems. As a rule, all these systems are integrated with each other and use API protocols. Yes, there were other protocols before. It used to be that each application set up had its own special protocol. Now everyone is moving to a standard API and trying to use it within a conventional model such as REST or some other data to make it easier to integrate with those applications. Because there's a lot of integration in today's world, and it's easier to have a unified integration interface. And IoT, cities, houses, cars, apartments, everything that is being used now in real life. If you bought a car in the last few years, you know that it's phone controlled one way or another. This is also done via APIs, but not just API from the phone to the backend. For example, if you talk about Volkswagen, Mercedes or BMW, but from the car itself to the manufacturer's cloud. APIs are used there too. You have to get it. It turns out that almost all traffic on the internet is API based. That's pretty much exactly the case. Yet the modern internet is API driven, and you can't argue with that. What's more, there are official statistics collected by various companies, and the data say exactly the same thing. Finally, starting in 2019, in fact early 2020, according to Akamai, which is one of the largest distribution networks on the internet, says that 83% of its traffic have been API call based, and it estimates the internet to be in that proportion. This was 2020, before the coronavirus, before the internet in general had grown 3 to 4-fold by various estimates, and the API has grown significantly also because the new sites that appeared on the internet at the time were almost all API based. No one builds a site using old technologies. Those 17% in 2019, early 2020 were old sites. No one builds the new sites using old technologies, almost no one. And the most interesting thing is that it is a double blind spot for security systems. API is an application programming interface. The API requires a different approach to its protection, and in fact, it is a blind spot for the application firewall and all the generations, which is why we're talking about API protection. On one hand, it's a trend, it's something everyone faces. You can't have a modern internet and a modern company, or even a company 5, 10, 15 years old without an API at all. It's just impossible. At a minimum, you've got some product that you bought. There is an API in it. And number two, it's absolutely a blind spot for security systems, so that we have to be protected. According to statistics, 40% of opportunities for an attack against web applications are related to APIs. That is, all of the potential attacks against web applications that we see, 40% can be attributed to attacks on the API. Now, this is always very serious statistics. You have three components of this system. Number one, the prevalence of technology. Number two, it is a blind spot. Number three, there are already attacks on this technology. And now a little bit about security and threats on API protection in a general sense, so that we understand what happens, what to protect against, what are the pitfalls, and what to do about them. API security can be divided in three main classes, or you could say it's of three pillars. The first one is authentication, the second is authorization, and the third is protection against intrusion. These three components form the interface to understand what is going on with API security, and the most interesting is that first two, that is authorization and authentication, are described as processes, guides, as ready-made solutions, and in general, the implementation itself rarely causes problems. Of course, there are vulnerabilities there, of course, there are rollout errors, there are other issues there, but people understand what to do about it. The reason is that the case is because the authorization and authentication mechanisms themselves have not changed much. There were barriers, there were tokens, there's roughly speaking JWT, JSON, web token, new technologies, so WAF and other things. But the concept that the user gets authenticated, then we authorize him or her, store the session, and so on, has not changed dramatically. And the solutions in there work well, are pretty predictable, and pretty safely out of the box. The first two pillars usually perform well compared to the third pillar, which is called intrusion protection. And this is the most important task. It's the newest one too. There are no approaches to solving it just yet. They are just now being designed. The community and professionals are just beginning to think about what to do so that API security in terms of protection against intrusion is at the same level as the unification of authorization and just as unified. What is the community doing about it? There's the most basic community, the most basic consortium that there is, and it is called OASP, Open Source Web Application Security Project. OWASP is known for ranking the most popular risks for apps. It's called OWASP Top 10. In recent years, literally starting in 2017 or 2019, there has been another rating list that is parallel to OWASP Top 10. It is called OSAPI API Security Top 10, and it is fundamentally different about everything inside. What is important to understand about that risk classifier? This is not about the name for vulnerabilities, this is not about types of attacks, this is about the names of risks based on reviews by experts who have compiled that ranking. They are categorized in a way that makes it convenient for those experts to categorize new incidents that come to them. You can think of it as a system for analyzing incidents that have already occurred. OWASP API Security Top 10 indeed does not exclude regular OWASP Top 10 injections, access, the vulnerabilities of normal web applications for APIs. They all work. That all stays in the same place, and another layer is added to that. These risks and ratings are therefore parallel. They are the second layer for OWASP API is superimposed on OWASP Top 10. You can't say that if we have OWASP Top 10, we don't need to talk about OWASP Top 10 for regular APIs anymore. We do. It's very important to understand. That creates a bit of a mess, and that's why there's a big problem for experts and people who are started out in security, because we don't have any approaches. All we have is some ranking. This ranking complements an even older inaccurate ranking, and we have absolutely no understanding of what we're fighting against, because it's so much harder to fight risk as opposed to types of risks, vulnerabilities, specific exploits, and so on and so forth. A risk could come from people, and we need to technically understand this risk. So for convenience, I've taken some time and tried to clean up the mess a little bit. So what's happening? Let's take an overall look at OWASP Top 10 using our three pillars: authentication, authorization, and intrusion protection. And we'll see that API 1, that is broken object level authorization, is about authorization. API 2, risk by frequency multiplied by impact, that is damage, and authentication error is not authentication. The next two risks from the top 5, data disclosure and no read limit, meaning no download limit, are already protection against intrusions that is covered by intrusion protection control. Next comes broken function level authorization again, and then all the other risks, the 6th, the 7th, the 8th, the 9th, the 10th, again, protection from intrusions. That is, we have such coverage that the authentication and authorization solution covers the following 3 of OWASP API security risks: the 1st, 2nd, and 5th. The 3rd, 4th, 6th, 7th, 8th, 9th, 10th, and specifically mass assignment, that is mass data application, security misconfiguration, a very broad risk understandably, injection, a back reference to OWASP API to regular OWASP Top 10, improper asset management, again reference to the regular one, and login and monitoring errors, also references to the regular one. All these risks completely pass and also require protection against intrusion. Here we get a little overlap between OWASP API and regular OWASP, but you shouldn't think that the other risks of OWASP have disappeared. They are there too, that's what we see. With that kind of approach to life, living makes a little bit more sense. Now at least we know that protection against intrusion is at least when and if we fight the risks from above and trust OWASP as community, and there's nobody else to trust. So we start looking at how a particular intrusion system fights these major risks. This makes a little bit more sense. A little bit about the complexities of API protection, a little bit about what we technically have to do for that, and how we actually deal with the 7 of the top 10 risks, and other that haven't gone away either. That doesn't mean that if OWASP made a list of 10, there isn't a tail of 100 ones out there. This means that the other 90 are less interesting to the community than the first 10 ones. And it says, well, let's look at it. One of the complexities of protecting apps, APIs, regular web apps, the classic apps that we have been protecting since the 90s in various forms. The first is the unique implementation. We have a standard that says how data should be transmitted, how calls should be made, what the endpoint is, what this large function is, and how to set that up. This is only a paradigm. Implementing particular paradigms up to the individual developer, and that's a big problem. Let's say we have a call that user makes, we have an understanding this user is a set of specific fields. Which specific fields, by which fields we will search for it, which query parameters will be described for this user, what combinations of these parameters will work, finally whether this call is the only one. All this is driven by the implementation. The paradigm does not describe it in any way. The second one is to support multiple versions simultaneously for backward compatibility, especially in relatively new markets for APIs themselves. When you need to support one group of clients, especially in B2B, supporting business apps with one version, others with another, these have paid for this version version, those can't program themselves in a new client for this API. This is a compatibility issue, and it arises much more in API because in websites it is a visual interface. It works or doesn't for all the users at the same time. Yet there are mobile and other exceptions, and they all have their kickers too. But the main thing is that we have version support specifically for APIs, especially for business apps, especially where there is some kind of paid subscription to some version, and you need to maintain it and keep it going. The third one is nested data formats. We say that there is a conditional data format such as JSON, but it can be any other format, XML and so on. But there are multi-layered investments which remain on the conscience of the developers. It is indeed them. Generally speaking, data encryption kills the ability to decode and detect payload, just as do WAF, application firewall, and so on. And as a consequence, we understand that multi-layered coding also contributes to that. And here we get a complete mess on our hands, because the security tools, it turns out, have to figure out on the fly how it is encoded, decoded, to try different options, apply the right encoding, and catch the attack there, which is actually a very big and complicated task. The third one is proprietary encoding format. Sometimes developers don't take an existing standard one, but write their own format. And if we have a format for encoding strained binary data, such as base64, for some reason, they will not like it. They will refine it, write their own, and this, of course, must support a security tool that was never designed and made for a specific implementation. Naturally, it won't work that way because it knows absolutely nothing about what have implemented. The fifth one is API clients, not users. The behavior of those clients is not one of the users, not of humans. They're robots. Their behavior is very different than the behavior if we try to block queries after the thousands, one in 1 second, and so on, can be strikingly different. There are some real examples from the life of different applications when, due to, for example, a connection failure, the client, once the connection is restored, starts trying to upload a huge bundle of data, or conversely download a huge bundle of data, which the time exceeds all its possible thresholds. This is a normal function. This is how errors are processed on this side, and this behavior is absolutely not users, but absolutely normal for the API. Processing this behavior presents a huge challenge and problem for an API security and protection solution. The sixth one is big data. We compress the data to make each particular query smaller, but we do it because there's a lot of data. Of course, in real life, in order for businesses to operate in today's world and make money, they need more and more data to absorb, consume, and transmit various data from one system to another, and those processes themselves may all be suboptimal, but that's not the point. It's about the fact that big data and high speeds put yet another limitation on security systems, so that it's still very fast, because the human's requirement for a site is not the same as a client's requirement in the form of a robot for an API. It is exactly because of lags, timeouts, and other things. Of course, if you understand the specific features of software programs, the program client, which is configured to download some reports, may drop out, go down, or apply for new reports, or not apply if the waiting time for this report is longer. A human, on the other hand, can wait. This is really the case, and thresholds at the limits that are set there, of course, may not be known to two parties, so those volumes of data, the lags, are major problems for the security tools. And the seventh one is the relevance of documentation schemes. Developers and maintenance operation are a little on different sides of the barricades, somewhat barricades, but the problem is that they do not communicate well with each other to improve the relevance of this system. Yes, there are systems, for example, GraphQL-based API, where the documentation is essentially automatic and the scheme will be published, but figuring out that scheme, what it does and how it does without a human description, is almost impossible. In real life, the relevance of the documentation prevents protection and security services from understanding the functionality that we see now and downloading the base, let's say, through that API method. Normal or subnormal, the documentation contains no definition of what normal. There is no definition in the documentation of what is the limit of 10,000 query records. Is it too little or too much? There's no definition in the documentation if an app, a particular API, started producing a lot of certain errors, with some status 504, for instance, whether it's normal or not, whether it should do it or not, under what conditions it should do that. In general, documentation is an issue for users for security, because when they need to eventually reconcile the behavior of potential attackers with, let's say, normal users, they have to rely on documentation, which usually doesn't exist. Security tools must therefore somehow sort out on the fly whether it's normal or not, and profile behaviors, and that's a major challenge for them. Next, I've written out 9 key criteria by which API security tools are selected, just to guide the people who do that, who do support operations, security developers, business owners, how to select these defenses. The first criterion is protocol. If you have an API that supports some protocol, security tool must support that protocol. Typical protocols: REST, GraphQL, gRPC, WebSocket. If we're talking about some kind of streaming, trading of fast messaging, SOIP, also known as SOAP. If you have files such as the XML scheme, it is an XML protocol, XML RPC, and so on. You just need to understand what protocols are used and check what security tool can support. And the second one is encoding formats. Within the protocols, there will be more encoding formats. For example, base64, JSON, maybe JSON inside JSON, and it's a data processing format. There may be compression tools such as QZIP. There may be XML, that is encoded documents inside JSON, and you have to understand that the security tools that you choose match the protocols and those encoding formats within protocols that you use. The third one is, of course, the types of attacks and threats. For example, the very injection API abuse, something I said at the beginning when I was talking about how authentication, authorization, and intrusion protection are spread out over the world with OSAPI API Security 10. The fourth one is a mechanism for detecting and blocking attacks. Whether they're signature-based, behavior-based, neural network-based, based on what they are, whatever, these are the detection techniques that will work to bring that benefit and to detect intrusions. The fifth one is the types of installation. Where this API product is installed. Inside the product API gateway is essentially a distribution proxy with a communication bus, or directly inside Kubernetes. If we are talking about private clouds and public clouds based on Kubernetes or Ingress, as a simple reverse proxy, as a sidecar. If we're talking about containerization or any other installation options, the installation option often determines the choice of a vendor in general, and the choice of a vendor is determined by that alone, simply because there are times when the infrastructure is not supported and the specific vendor cannot fit into that infrastructure. It doesn't matter what it supports and what it doesn't support. The sixth is auto-scaling. In real modern world and modern APIs, there's no doubt that that's why we're moving to the cloud, which is to auto-scale and use as many resources as we need at the end time point. If we have a heavy workload, we should have enough resources without buying server racks in advance. If the load has gone down, we should pay less. The security system, therefore, must also be able to play that kind of a harmonica. The seventh one is determining the app structure. We've said earlier that in addition to the basic paradigm and the exchange data protocol, there is a logic inside, and some of this logic is driven by the structure of the API themselves. The number of calls, the number of business functions, like add a user, delete a user, send an order, etc., determination of the API structure so that the person can see security system operator, or a developer, or a manager, or a service or support employee should say what's going on with the API right now, what structure they have, what works and where it doesn't work, and so on and so forth. The eighth one is monitoring and logging. It is clear that the security tool must be able to monitor and log events, but the main thing is that monitoring and logging should be built into the monitoring and logging system that is in place at a particular organization. Of course, it doesn't happen that this monitoring and logging live somewhere separately. That is, it happens, but it works very badly. And the ninth is CI/CD integration, continuous deployment is probably de facto a standard for developing any modern application, including APIs. As we have understood, APIs are the backbone of modern applications, integrating security tools with, in fact, the pipeline. That is the process of continuous development, continuous rollout, integration, testing of the app. This is something that is just necessary in today's world, and this is the criterion for choosing solutions in terms of API security. A little bit about technical details. How does API query analysis work after all? Why is it different? We can say that the security system must support, and usually do support, some kind of intelligent parsing. That is, parsing as an opportunity to understand the structure of a query, take it apart, check the fields, and eventually find these malicious or non-malicious data. For example, you have a request for authorization. It is called by some method, /API, /v1, /auth, user's name and password, and transmitted to field You have to sort out that JSON has a field for username, a field for password. They are mandatory. Username should look like an email. It should have an @ sign in it, a dot sign at least. After the dot sign, something from the list. The password should contain 12 plus characters, so on. The system has to pass all of this and then give it back for the check-in, either by signature or by any other means. This very email stream, or a piece of it, or a password, or a piece of it after the data are processed. If we give away such a big chunk with JSON, that is the whole body of HTTP query, of course all the signatures will work because there are special characters, beaks, quotation marks and so on, characters more than and less than, because it's normal to use special characters for coding data history, and we'll skip the string data inside. Accordingly, it must be done. It's important that we not need to upload the scheme. There are many solutions. They fall into two categories: those that require downloading a scheme and those that do not require downloading a scheme. Downloading a scheme is good, but there's fraught with the risks because of the fact that first, the scheme is incomplete, and second, it's irrelevant. And so modern solutions, more modern, more reliable solutions, know how to do that scheme based on the traffic analysis application responses, because it's a fact that you'll never have an up-to-date version of the scheme. Developers can go wrong. Moreover, even if you close everything according to the scheme, there is no guarantee that initially there will be no error in the application that goes according to the scheme. A scheme is a format for describing data fields and so on. It's there as OpenAPI or Swagger, or for REST API, WSDL for SOAP, as any other scheme for other protocols. For GraphQL, there is an introspection query, a special query for that. But it's important to understand that there will never be a perfect scheme. An error can be found in any scheme, and it may be irrelevant, so modern security tools determine the flowchart on the fly and work using it. The third passing criterion is the automatic data recognition format. We've already talked about a JSON, XML, base64 and so on. They should be done automatically without that traffic detection. Under the scheme will not work. Even if there's a scheme, the scheme won't have, no modern API scheme describes nested encodings, nor does it say that there's a zipper inside this field and this and that, and it's not supported. So you have to dig deeper, and you have to dig deeper because the data is there and the developers encode it however they want it. It's necessary to apply parsers and decoders. There's no point to just recognizing the data and decode complex strings when they are sequential. It's just one of the use cases. Now, that's called deep API query analysis, and that wasn't in the simple forms of, for instance, websites that we used to send, and it wasn't in other things. This all appears in APIs. There's something to keep in mind. Auto profiling, by the example of what we have, there's no special commercial part to it, just an example of a call tree. We see the traffic, we analyze the traffic, and many app protection solutions do the same. For the API, the traffic looks a little different. Accordingly, business logic functions, mandatory and optional parameters, the scheme of the application, which appears on the basis of the traffic analysis, that is, what exactly there is in the application, not what is written in the documentation, but how it exactly works. All of that is important to display on the basis of traffic analysis, and this is usually handled by security and operations support and so on. And the developers too, especially if we're talking about the DevOps process, where we have the ability to integrate developers directly into the production cycle and collect feedback on how that app actually works. Once again, the real life is very different from what has been originally intended, especially in production. Everyone understands this very well. And now the definition of shadow API. By shadow API, we mean undocumented methods. Sometimes they are backdoors, remote access tools. Sometimes it's just errors, bugs, a lack of documentation. Sometimes it's a challenge that have been left behind from integration. There are many reasons for shadow API to emerge. We could talk about separate report on that, and if this topic of interest, maybe next time I'll tell you something about it, where they come from, how they are dangerous, and so on. The Shadow API is one of the most iconic and meaningful places in API security. Well, thank you very much for having listened to this report. I will be happy to have any feedback for this report, and I will be happy to see you at the next event. Thank you very much, and have a nice day.